So now let's do strategy number two, computer simulation. What's the big benefit of a computer simulation? Well, you can run lots and lots and lots of trials very, very, very quickly. So under number two, strategy number two, it says to get an even better idea of the long run, because remember, that's what we're interested in for probability. The long run proportion of times zero matches happens, we can program the simulation on a computer. Now, there's a web applet called Random Babies. So this was actually designed by someone at Cal Poly, so it's pretty cool. Dr. Rossman and Dr. Chance are both full professors at Cal Poly. Now, babies aren't cards, I know, but you'll see that it does work. So we're going to use Random Babies. It does what the cards do, but you can do many, many times. So in this way, what's going to happen is I've got four babies. So in other words, four people with phones, and I'm going to do just one trial so we can see how it works here. So the stork comes, goes to the hospital, and then the babies get to go home. Where the sons are babies who got to the right place, and where it's raining, the babies went to the wrong house. So we'll notice that here we've done one trial. So once, just like we did originally, we did it one time. In this case, there were exactly two matches. So what's the probability, the estimated probability of zero matches at this point? Well, it didn't happen, right? So the estimated probability of zero matches would be zero. Now, can we do this a lot more? This one time great? No, is 10 times great, better than 100 times better than that. If I put in 999, what it's going to do is it's going to do this 999 more times so that we end up with 1,000 trials total. So I ran 1,000 reps is what it showed here. Record the estimated probability of zero matches. Well, here we can find that. You can see here's the frequency, in other words, the count of the number of times that zero matches happen. Now, if I go across, I go to zero matches, there were 356 out of the 1,000, and the proportion of times that there were zero matches, so in other words, the probability is 0.356. Will this estimate be the same if I do another 1,000, let's say do another 1,000 reps? Do you think we're going to get exactly 0.356 again? Well, let's try it. Let's reset. I'm going to put in 1,000 this time. I'm going to randomize, and I get 0.378. Are they close? Yes. But remember, these are trials. This is when we're talking long run, we're not even talking thousand, tens of thousands, we're talking millions upon millions. Will the estimate be the same? No, it won't. Let's try instead, let's reset and let's do 10,000. So even more. The estimated probability of zero matches is 0.373. Now, what we found for 1,000 trials versus, or 1,000 repetitions versus 10,000 repetitions, the numbers are actually pretty close. So here's the information from what we had in the applet. I recorded it as we went along. I recommend doing this yourself. It just gives you a better feel for what's happening. Note the more repetitions result in a better estimate, an idea of the long run pattern of outcomes. We're just choosing 1,000 or 10,000 because they've been empirically found to be large enough numbers of repetitions. Could I choose a number such as 5,231 or 21,593 to do those number of repetitions? Sure. Once again, these are large numbers. They will give you good estimates. However, as we do this, do you think every time you run it, I mean, most of the time you run it, you're going to get a slightly different number? Yes. And that's one of the downsides of doing it by simulation, either by hand or by computer.